Welcome viewers. In this video, I'll demonstrate with the help of models the projections of solids. As you know, we divide the space in 4 quadrants in engineering graphics. I'll call this quadrant as the first quadrant, this as the second quadrant, this one is the third quadrant, that is the fourth quadrant. We prefer to have the object placed in the third quadrant. So this way the object will be placed. So you can see the object when it will be placed. So your VP, you are viewing from the front direction and you are viewing through the vertical plane. This is the plane of projection for the front view. So the front view, whatever you view from here, so you assume that this was a transparent plane and it will project on the front view. So front view will be below the XY line, and similar way the top view is captured by the horizontal plane. So horizontal plane from this position has been taken, and this way whatever was projecting on the horizontal plane, so that will be moved up, and whatever was the top view, it will be projected on up or above the XY line. So overall this is the quadrant that we are following. Now let us say we are told about a triangular prism. So we need to demonstrate or we need to draw the projection of a triangular plane, a triangular prism, which is resting on its base on the ground. So this way the triangular base, you can see it's a triangular prism, it's resting on the base on ground. So we have this surface as the ground because it is parallel to HP, this is the horizontal plane, and we maintain it in this position. And so in the top view you will see the triangular base, and in the front view you just see the rectangle. Okay, so that is the simple position that you can draw. If suppose you are told that the axis of the solid is inclined to ground, currently it is perpendicular to the ground, and it is parallel to VP. So this was VP, so it is parallel to VP. Let us say it remains parallel to VP. So for you this is the position, and the axis remains parallel to VP, and you are told that the axis is inclined at 60 degree to the ground, and it is parallel to VP, while the solid is resting on its base edge. Now ultimately this is the position. Okay, so you can even say this is the position. You will understand that from the top view it will look like this. That means it no longer has the true shape of the base. So when you need to draw projections of this type, when the solid gets inclined, or when the surface of the solid is not true shape, in that case you need to draw it in 2 stages. In first stage you deliberately keep it in such a way that you get the true shape of the base. Now whenever your axis is inclined to the ground, in that case you will deliberately keep the axis perpendicular to the ground, so that in the top view you get the true shape, because this true shape is essential for you to get the apparent shape. So as has been demonstrated in the examples, graphically, so because from the true shape you will draw the projection lines, and then you will be able to get the apparent shape. Directly reaching the apparent shape graphically is not possible. So that is why you will first draw the initial stage so that you get the true shape of the base, and then you tilt it. In addition, in the initial position you have to see that if the object is finally resting on certain edge, then that edge must be perpendicular to the xy line. So, in the current position you can see easily this edge, finally it is resting on this edge. This edge, if I draw perpendicular, then it will help me from front view to have this as a point, and I can have the rest of the base lifted so that the required tilt can be given. The required tilt can be given like this while still maintaining the edge. Suppose if I take it in this position, what will happen? If I take it in this position, now when I tilt the front view, basically how will you give the inclination to the axis? You will tilt the front view like this. But if you do that, your solid is now resting only on a corner. Okay, so rest of the plane it lifts up. So it is not possible to keep the edge. It is not possible in this way to keep the edge in the, or base edge in the ground. Base edge is not on the ground, only the corner is on the ground. If you want to keep the base edge on the ground, you need to choose an initial position in such a way that this base edge in the front view it looks like a line, and how it looks like a point. The base edge should look like a point, and that will be possible only if this base edge is maintained perpendicular to the xy line. So you can easily see this was the xy line. So this is the xy line, you can see, and this is the real position. So that xy line is like this, and this line is like this. That means these are perpendicular. So this way you will be able to reach the final position. Okay, so this was about the case when the inclination is with the ground. If the inclination is with VP, there are many cases like that. You may be told that the solid is resting on ground on maybe its rectangular faces. So about the nomenclature you are clear, so that these are rectangular faces. These are called vertical faces also, and these are called triangular bases, and these are called the bottom ones, these are called, these lines, these are called base edges, and these are also called base edges. These may be called as top base edge if it is lying on top, bottom one may be called as bottom base edge, and these lines or these edges, these are called vertical edges for a prism. Okay, so these are corners, base corners. You may be given a situation when the solid is resting on its rectangular face on ground. So it is resting on rectangular face which is lying on ground. Now if you draw like this, you don't, if you draw the initial position as is shown here, you won't get the true shape of the base. So better thing is to choose this position, or you need to choose this position so that the base as a true shape is first obtained. So that is the purpose of initial position. Then you may be told the solid is resting on the rectangular face on ground, so that the axis is inclined, let us say, at 60 degree to VP. If the axis is at 60 degree to VP, so first you will draw this position, its front view you will see as a triangle which is just on the ground line, and in the top view what do you see? You will see two rectangles like this. You see two rectangles, and in the second position the front view or the top view as it is, top view is rotated like this. Whatever top view you obtain, you rotate so that the axis, which earlier was perpendicular, in this position it was perpendicular, it is given an inclination as per the definition or as per the problem statement, and the front view will take this shape. Okay, so front view you are able to see, and a top view anyway just the tilt has happened. Earlier it was like this, now the tilt is like this. Earlier it was in the top view the axis was perpendicular to the xy line, now the axis will be at 30 degree to the xy line. Okay, so this was about the prism. Now I take the case of let us say a pyramid. It is a square pyramid, you can see it has a square base, and you have in a pyramid one vertex and one base, and you have 4 slant faces and 4 slant edges. These are slant edges and slant faces. These are base edges. These are base corners. This is apex. Now, about the condition when it is, let us say, having axis inclined at some angle to the ground. If the inclination of the axis is with the ground, then the initial position is taken in the similar manner as you have taken in the case of prism. So, you see that if the axis is inclined to the ground, then initially it should be perpendicular to the ground. So, currently it is perpendicular to the ground, and the top view you see the square. So, it may be told to you that the 2 base edges, they are parallel to xy line or parallel to maybe the VP. So, then this is the condition. If you are told that the base edges, they are equally inclined, then this is the position. Then this is the position in the top view. The top view will look like a square like this. If you are told the base edges are parallel to the VP, then this is the position. Okay. So, let us say we maintain this position. Now, you may be asked, the axis is making, let us say, 60 degree, and the object is lying on one of the base edges. So, that way also it may be told. You may not be directly told that the base edges are parallel to VP, etc. You may be told it is resting on base edge when the axis, and the axis makes an angle of, let us say, 60 degree. So, then if it is resting on base edge, so you need to keep the base edge perpendicular to the VP or perpendicular to xy line in the top view. Then the base edge will turn into a point, one of the base edge at least will turn into a point, and that point can be maintained in ground, and this way you can give a tilt. So, first position you can choose this, and this will be the top view. That will ensure that this base edge is a point in the front view, and that point, when the whole base is lifted, so that point will remain, but actually it is a line only, it will remain in ground, whole of the line is remaining in ground. If you are told the base or it is resting, it is having the inclination with the ground, but the solid is resting on the base corner, then you maintain the base corner at the extreme, and normally you keep it in the symmetric position like this. Top view should look like this. Even in this case, if you may say the base, you can give it a tilt, and you can get the like, rather than in symmetric position, you may say this way I maintain and this way I give a tilt. So you will unnecessarily complicate the things. You will have number of edges visible. So better thing is, so you maintain symmetry. If nothing asymmetric is mentioned, you maintain symmetry. So this way you will maintain symmetry. If you are told that it is resting on its corner on ground, initial position you choose like this, so that the top view is like this. You will draw the top view first, and based on that you will complete, you will be given what is the height of the solid, and the baseline you will know from the top view, and that has already been demonstrated graphically, and this way you give the tilt finally. And you may also have a problem. So in one problem it is told that the tilt is such that the slant edge, one of the slant edge, it becomes perpendicular to the ground. Then this is the position. Okay, so then the tilt, it is resting on the base corner on the ground. You may, the statement may be like this, that the base or the slant edge that contains the base corner on which it is resting, it is perpendicular. So then the initial position will be similar to this. So you will draw the top view a square like this, and front view you will be able to get, and then you give the tilt such that your front view it has this as the true length, and this true length it goes into the vertical position. Earlier it was tilted, you make it to vertical position, and in that case what you see from the top? From the top, what do you see? You see that these surfaces, you note that earlier from the top you are able to see all the 4 slant faces as surfaces. Okay, so you are able to see the 4 surface, you are able to see all slant faces. But if I rotate it like this slant surface and this slant surface, they become vertical in the top, from the top view. From the top view, if you see, so this is how it will look from top. I am just showing it to you. So these surfaces, they become vertical, and from top you will see them just as a line, and you will see only this surface and this surface is visible. So this problem has been covered in graphical form also. So you can see, so this is the way so solid model looks like, that is how we have drawn that. Okay, so this was regarding the position when of the pyramid when it is having the axis inclined to the ground. If the axis is inclined to VP, what will you see? If the axis is inclined to VP, and you may be told that it is let us say it is having the apex away from observer. If the apex is away from observer, so then this will be the position. Your quadrant planes are like this. This is the position. So since these are transparent, I have to show it to you, but you assume that there is one vertical plane here, there is one horizontal plane here, there is a ground here. It is resting on ground, but the plane of projection is HP only. Plane of projection is VP and HP both. In the front view, VP. So front view will remain below, and the for the top view, the HP it shifts like this, and that makes the top view above it. Now if this way, if the apex is away from the observer, you are the observer at this moment. If apex is away from the observer, you will see that the impression on the top view will be such that it will appear upright. Okay, impression will be or the projection if you view, if in this case when the apex is away from the observer, you will see that it is in the upright position. But if it is towards you, if it is towards the observer, observer is where? Observer always is on this side. For first angle also observer is here. For first angle, the plane of projection is after the object, but for third angle, plane of projection is between the observer and the object. So that important point, so will always be maintained. Now I was saying, so this way your position is when the solid is resting on ground with the axis parallel to the ground, it is resting on base edge with the axis parallel to the ground, and if it is if just this position is given, so in that case the top view, so because top view has been captured here and it will go like this, so due to that reason the top view will show it inverted. So that point you need to keep in mind. So how the solid will appear in the top view and front view. So particularly for pyramids, when the apex is away or apex is towards the observer, so this difference is sometimes little confusing. So through solid models it should be clear enough. Okay, so similar way you may also be told that it is the apex is towards the observer, let us say, and it is making an angle, and the axis is making an angle with VP. How much angle? Let us say 60-degree angle. So currently it is 90-degree angle. Currently the axis is making 90-degree angle. So you may choose initial position like this with the same principle. What is the principle for determining the initial position? You need to see that if the axis is inclined to VP, you need to maintain it perpendicular to VP. So in this position it is perpendicular to VP. So this will ensure that in the front view you get the true shape of the base. That true shape of the base will help you to draw the rest of the projections or the final projection, because you are given the statement and statement is given about the true shape of the base. So you need to first transfer that information in graphical form on the drawing. That is why you need in the initial position the true shape of the base. So you capture that true shape of the base, then you go for the second stage, because directly apparent shape you do not know how much this will look like. Okay, so if it is tilted, how much this base edge will reduce in length. So that is done through graphical method. So so this is it. Just when the axis is tilted, so this is how the front view will look like, and from the top view also almost a similar thing will show up. So in the it will look almost similar. So in the little difference will be there, so that graphically can be drawn. Okay, so it has also been demonstrated. You may also be told sometimes it is resting on slant face. Then also when it is resting on slant face, that slant face, the base edge containing that slant face, you will maintain. If it is on the ground, so you will maintain it perpendicular to XY line, so that it can be tilted. If the solid is resting on the slant face, then the base edge containing that slant face you will maintain perpendicular to XY line, so that it remains as a point and so that it can be tilted around that base edge, and finally this way it can be shown. You may be given that the axis is also making, or base edge is making, let us say, an angle of 60 degree. So then the base edge making an angle of 60 degree, this may be the condition. So then from front view this way you can draw, and from top view, so graphically you will know so how to deal with these problems. So the solid models have been used just to demonstrate how it will look like, so that it helps you to visualize the things easily. So another thing that you may have is about the tetrahedron. So this particular solid is called tetrahedron. So it has 4 faces, and all faces are triangles. Even the bottom one is also a triangle. So this base and other faces all are congruent basically. So this is a solid which is called the tetrahedron. So many times you may be asked, you draw a tetrahedron with a given base edge. So what will you do? So in that case, so first thing is this base edge, you draw the triangle, equilateral triangle first, so that the base is captured. You will capture this, and for the cylinders, so you may be told sometimes the cylinder is lying on the ground with on the circumferential or on its generator, and its axis may be making an angle of let us say 60 degree with Vp. Then final position is like this, isn't it? So it is lying on the ground on a generator. These are generators. There are infinite number of generators in a cylinder and also in a cone, but in the cone we have the slant generators. Okay, so now this cylinder is finally resting like this, but you note that here an ellipse is formed. So you don't know how much is the dimension of the ellipse. So what you do to get that? So in graphical manner, so what you do? So first you exploit that same procedure. Initial position you draw in such a way that the true shape of the base is visible to you. So because its axis is inclined to Vp, you maintain it perpendicular to Vp first. So it is perpendicular to Vp currently, and you are able to see its true shape, the true shape of the base. So that is the circle, and its top view will look like this. It's a rectangle. Top view will look like a rectangle because these are the lines of tangency. So it looks like a rectangle. And finally what you do, that rectangle you tilt by the given amount. When you tilt it, so you will get the lines, so reference lines, so that you know how much is the dimension of the each ellipse, and this is how it will look like. You note that the front ellipse or the base which is towards the observer, this is completely visible, but this base is not visible. So this comes, portion of it is hidden, portion of it is visible. So that is the simple solid, and you will be able to imagine in an easier manner. So that has been the objective of this video. So thank you.